Endothermic reaction. So we learnt about exothermic reaction. Then what is endothermic reaction? The reaction in which heat is absorbed during the reaction are called endothermic reactions. Example, nitrogen when reacts with oxygen, it gives one second. Okay, when nitrogen combines with oxygen, it give one along with heat, it gives nitrogen oxide. Means nitrogen combines with oxygen, it gives nitrogen monoxide, where heat is consumed. This will call as a endothermic reaction, where nitrogen gas when combines with oxygen gas with along with heat, it gives nitrogen oxide as a product. It is a endothermic reaction where heat is involved for this reaction. Note here, all decomposition reactions require energy in the form of heat, light, or electricity. Hence, all decomposition reactions are said to be endothermic reactions. We can say that all decomposition reactions require heat, light, or electricity. Even we learnt in decomposition reactions with thermal decomposition, electrolysis, and photolysis. So, where the heat is required for the breakdown of larger compound into simple compounds. So, all decomposition reactions we can say as we can say that they are endothermic reactions. So, let us watch the video to understand endothermic reactions. So, here this is a ferrous sulfate which you call as green vitriol. The ferrous sulfate, when we heat, it converts into a simple compound, that is a ferrous oxide, sulfur dioxide and sulfur trioxide, which we saw in a previous video, where it decomposes to give simple products. And even water splits up into electrodes. When you connect electrodes between water, splits up into hydrogen and oxygen. So it is also a decomposition reaction. And decomposition of silver chloride into silver and chlorine. So here also heat is required, sunlight is required. So all three where heat in the form of what you call thermal heat, electricity, or light. So the reactions in which energy is absorbed for the breakdown will call as endothermic reactions. So these are the endothermic reaction example. So you should answer whether photosynthesis is a exothermic or endothermic reactions. Next type of reaction, that is sixth one, oxidation reduction reaction. It's a very important reaction, oxidation reduction. Then what is oxidation? What is reduction? Oxidation is defined as a process which involves gain of oxygen or loss of hydrogen, or which you can say that oxidation is a process where it gains oxygen or it loses the hydrogen. Addition of oxygen or loss of hydrogen we can say as oxidation. Addition of oxygen or loss of hydrogen. In this reaction, when copper reacts with oxygen, it gives copper oxide. See very carefully, copper plus O2, it gives copper oxide. Copper doesn't contain oxygen, but when react with oxygen, it gets oxygen. Means copper gain oxygen. Means if copper gain oxygen, then it is oxidation reaction. Copper is oxidized. So this is an example of oxidation reaction. Reaction of copper with oxygen is an oxidation. Gaining of oxygen also, it's not compulsory that if copper gained oxygen, it has to lose hydrogen. No. Any reaction, if gaining of oxygen or losing of hydrogen, if we see, then we can call it as oxidation. I will tell you when we lose hydrogen in next reactions. I'm going to tell you. Just keep in mind the reaction which gains oxygen or which loses hydrogen, both will call as oxidation only. Second example, magnesium reacts with oxygen, it gives magnesium oxide. Here also again, magnesium has acquired or gained oxygen. Magnesium gained oxygen, so it gives a product as magnesium oxide, MgO. Before it was magnesium only. After reacting with oxygen, it got as a magnesium oxide. It gave magnesium oxide. So that it is also an oxidation reaction. An opposite of this oxidation is reduction. What is reduction reaction? It is defined as a process which involves gain of hydrogen, loss of oxygen. Oxidation is gain of oxygen, loss of hydrogen, whereas reduction is gain of hydrogen, loss of oxygen. If a reaction, in the reaction, if hydrogen gains or loses the oxygen, we can say it as reduction reaction. So I will give the example. CuO plus H2, it gives Cu plus H2O. See in the student's reaction, CuO is nothing but copper oxide. Copper oxide, when reacts with hydrogen, it loses the oxygen from this, means copper oxide loses the oxygen and becomes only copper. So how it loses? This hydrogen has helped to lose, means hydrogen has reduced that oxygen, means hydrogen is a reducing agent. So copper oxide is reduced to copper, so hydrogen is reducing agent, whereas copper oxide is a oxidizing agent. So where CuO plus H2, Cu plus H2O means copper oxide. Now before it was copper oxide, but afterwards, after losing oxygen, it becomes only copper, means it has lost oxygen first. Okay, then afterwards in product we got hydrogen. Hydrogen is gain oxygen. This we can't say as oxidation, because in reactions only, if oxygen or addition of oxygen or addition of hydrogen takes place, then we can say that as oxidation or reduction, depending upon the reaction, only in reactants only. Okay, the next, zinc oxide reacts with carbon, it gives zinc plus carbon monoxide, means here carbon reduced the zinc oxide to only zinc, means oxygen is removed from the zinc oxide, so that zinc and carbon monoxide we got as a products. So here carbon is a reducing agent, where carbon because of carbon, zinc oxide has lost oxygen and it gets only zinc. Carbon is reducing agent. Next, we know that separate definitions we learned: oxidation, reduction. Next, we are going to learn about redox reactions. What are redox? If one substance loses hydrogen, there must be another substance which gains hydrogen. Such reactions which occur simultaneously are called redox reactions. Both oxidation and reduction reactions occur simultaneously. What is this? What is how can we say that? How can we know that both occur simultaneously in one reaction? For example, in a previous reaction, if you see here, one reaction, copper has gained oxygen, it becomes copper oxide, and in another reaction, zinc oxide has lost oxygen and becomes zinc only. But here in this reaction, redox reaction, losing of hydrogen and gaining of oxygen both occurs, means addition, oxidation, reduction, both are occurs in one reaction only, single reaction, that is a redox reaction. We'll discuss that. In this reaction, hydrogen sulfide, when reacts with chlorine, it gives hydrogen chloride plus sulfur. See, oxidation, reduction both are occur here. Hydrogen sulfide converts to sulfur, means in hydrogen sulfide, sulfur has left the hydrogen from that, means sulfur removed the hydrogen from that, and sulfur become alone. So here hydrogen removed from that sulfur, means it is a reduction. It is a reduction. If hydrogen removed means addition of oxygen and removal of hydrogen, I said in the previous class. So removal of hydrogen takes place here. So means it is a it is what removal of, sorry, it is not reduction, it is oxidation, because addition of oxygen or removal of hydrogen, we can say that oxidation reaction. H2S has lost hydrogen to form sulfur, hence H2S has been oxidized. This hydrogen sulfide has been oxidized to sulfur, means not only adding hydrogen, even removal of not only adding oxygen, removal of hydrogen also an oxidation reaction. So sulfur has left the hydrogen. By that hydrogen sulfide becomes sulfur. So here hydrogen sulfide becomes sulfur. So hydrogen sulfide is, we can say that hydrogen sulfide has been oxidized. And chlorine, see in this next reaction, chlorine has gained hydrogen. See here, this is only Cl2, two chlorines are there, but it has gained the hydrogen which has released from here. It got the hydrogen, means this chlorine received the hydrogen. We discussed that if removal of oxygen is reduction, not only that, addition of hydrogen also reduction only. See here, hydrogen is added, so it is reduced, reduction, it is reduced. Chlorine has gained hydrogen to form HCl, means chlorine has been reduced, chlorine reduced to HCl. Reduced means it gained hydrogen. Reduction is not only removal oxygen, it is gaining of hydrogen also, reduction only. Then next, which are the reducing agents and oxidizing agents? See, reducing agent and oxidizing agent both are in reactants only, not in products. H2S gives hydrogen, hence H2S is the reducing agent. H2S has left hydrogen, so it is a reducing agent because it helped the chlorine to become HCl. So H2S is a reducing agent, whereas chlorine gains hydrogen. Chlorine hydrogen oxidized to sulfur, but it is reducing agent. Chlorine gained what you call hydrogen, but it helped for oxidizing the sulfur, so it is a oxidizing agent. Chlorine is oxidizing agent, whereas hydrogen sulfide is reducing agent. Means one I will clarify here, don't get confused. Hydrogen sulfide oxidized to sulfur means it is reducing agent. Chlorine is reduced to hydrochloric acid, means it is oxidizing agent. Opposite, if hydrogen sulfide if it left, it will be the reducing agent. If chlorine received hydrogen, then it will be the oxidizing agent. So next, here you can tell me which is oxidizing agent, which is reducing agent. Identify which is oxidized, which is reduced in the following reaction. So let us understand what is oxidizing, what is reducing agent. Copper oxide reacts with hydrogen, it forms copper and water. So copper oxide reduced to copper, means it has left oxygen, it has removed the oxygen. So here it is reduced or oxidized. Oxygen removal of oxygen is nothing but reduction. Yes, hydrogen gains oxygen. We know that gaining of oxygen is removal of oxygen, what we call reduction. Gaining of oxygen, oxidation. If addition reaction and oxidation and reduction both are in one reaction, we can call it as a redox reaction. So here which is reduced, copper oxide is reduced to copper and hydrogen is reduced to hydrogen is oxidized to water. So which is reducing agent here? So copper oxide is reduced in the sense hydrogen is reducing agent. Hydrogen is oxidized in the sense copper oxide is oxidizing agent. Are you understanding which is oxidizing agent? Oxidizing agent is copper oxide, which is helped for oxidation. Reducing agent is which is helped to reduce, and both are oxidizing and reducing agents are from the reactants only, not from the products. Copper oxide is reduced to copper, which will help to reduce that hydrogen. So it is a what you call reducing agent. Hydrogen has gained oxygen, so that it becomes it oxidizes, which is helped for oxidized copper oxide. So this is oxidizing agent. Copper oxide is oxidizing agent and hydrogen is reducing agent. I hope you understand about the reduction and oxidation reactions. The next class will discuss about some more last concept, some more examples we'll see, and we'll see the last concept, that is corrosion and rancidity. Thank you.